How's it going, ladies and gentlemen? Mr. Donnie here, looking at 14.6 reaction mechanisms. All right, number 30. The mechanism for the formation of the product X is blank. They give you two elementary steps, one's slow and one's fast. So we know the slow one is the rate determining step. Just a little review for that. And the question is, what is the intermediate reactant? So an intermediate is just there in the in-between steps. So it's made in one step and used up in another step. So if we take a look here, first reaction is making D. But then in the second reaction, D is being used up. So because it's on the left side and on the right side, we know that that is our intermediate. So it's the product of one step, and then it's the reactant for another one. All right, so that's pretty much how you can tell what an intermediate is. A catalyst is used in one step first and then created in a later step. So you're not losing any of it. That would be a catalyst. 31. For the elementary reaction below, what is the molecularity and the rate law? So molecularity has to do with, all right, well, we got two molecules here. They don't have to be different molecules. It's just how many molecules are involved in that step. So to say two molecules, we say bimolecular. And the rate law would be R equals K. And because this is an elementary step, we could use the coefficients to figure out what order it is. So NO3, if it's blank in front, we know that it's really a 1. So the rate law would be R equals K times NO3 to the 1 times CO to the 1 as well. 32. A possible mechanism for the overall reaction. This is these two steps. And then if you see, the second step is the slow step. And it wants us to know what is the rate law for the formation of NOBR based on the mechanism. All right, so we're going to have to do this in a couple of steps. First step that we're going to want to do is the rate laws for each. So once we got that, then we're going to solve for the intermediate. I'll show you what I mean. So for this one, the rate equals K NO times BR. Now this equilibrium also tells us that there's a reverse reaction that is the same rate as the forward reaction. So R equals K1 for the forward reaction, which also has to equal the reverse reaction. So K2 times the concentration of NOBR2. Now this is important for the next step. So we're going to take a look at the rate determining step. So the R for the rate determining step would be K2. Oh man, totally messed up. So over here, this shouldn't be K2. That should be K to the minus 1. This is K2. So K2 times the concentration of NOBR2 times concentration of NO. Now there's an issue here. If we take a look at the elementary steps, we can see there's an intermediate, NOBR2. NOBR2 is an intermediate, so we can't leave it there in our rate law because it's not something that we can measure. It's just an in-between step, right? If you take a look at the equation, we have BR2 and NO. So our rate law has to be in terms of BR2 and or NO. Can't be NOBR2. So the next thing that we're going to have to do is to solve one of these equations for an intermediate. So if we take a look at that first equation, the first elementary step, we can solve for the NOBR2 in terms of reactants that are actually there. So we get concentration of NOBR2 equals K1 NO times BR all over K to the minus 1. Mr. Donnie, how did you do that? Well, this is what I wanted. So I got to divide each side by K to the minus 1 to get it by itself. All right, these two rates are equal. The forward and reverse are equal, which is why we can set up the equation here with that equal sign. All right, so now what we're going to do is we're going to plug this in for our NO-BR2 in our rate law, because we got NO, we got BR, which are reactants, so now we don't have an intermediate in there anymore. So we get rate equals K2 times K1 NO BR. Oh, I'm sorry, I forgot 2 is on all these, right? NOBR2 all over K to the minus 1 times, well, what's left in this equation, concentration of NO. Now, these K's are all just constants. They're just numbers. So what's going to happen is you can combine them to give you a new K, a new constant. So what this is going to simplify to become is R equals K times, well, we got 2 NOs, so NO squared, and we got 1 BR2. So this is our rate law. Now, what I normally do is when we have these K1, K to the minus 1, and K2, is I usually just ignore them because I know they're all going to combine to become just a new K, a new constant. So I usually just ignore them when I go do the work. And I'll show you what I mean in the next problem. So it says mechanism of reaction is shown below. We got a fast step, we got a slow step, and then we got another fast step. And I want to know, well, what is the overall reaction? So in order to do this, you got to look at the intermediates and figure out what cancels out. So again, we got an equilibrium here. We got 2 steps. Well, N2O2 is made in the first step and it's used up in the second step. So I know that's an intermediate. It cancels out. Anything else do that? Well, in the second step, N2O is made, and in the third step, N2O is used. So what are we left with? Anything else cancel out? Nope. So we're left with 2 NOs and 2 H2s, giving us 2 H2Os and just 1 N2. So that is our overall reaction. I'm going to erase all this so I can see it better. All right, which compound is / are intermediates? Well, we already figured that part out, right? N2O2 was an intermediate, and so was N2O. So those two things were intermediates. All right, so now here comes a little bit more tricky part. Predict the rate law based on this mechanism. So because the slow step is a rate determining step, we know that the rate for the whole reaction is going to be, R equals K N2O2 times H2. But again, N2O2 is an intermediate, so we got to solve for N2O2 in terms of a reactant that's not an intermediate. So we're going to take a look at this first reaction. All right, well, it's in equilibrium, so the rate of the forward has to equal the rate of the reverse. Well, I know that N2O2, that rate equals K times N2O2, which has to equal the same thing on the other side, the rate of K times NO squared, because I got 2 of them. There's 2 of them right here, so it's going to be 2 no's. All right, well, so I can substitute this in, right? I can put in NO squared instead of N2O2. So I end up with a rate equals K times NO squared, because of that substitution up here, times concentration of H2. So that's pretty much it. First step, rate laws. Second step, replace intermediates. And then third step, write out the answer. Simplify and combine like terms. All right, so that's it. Hope you found that helpful. See you in class.